Hi, everyone. Thank you for coming to the talk. I appreciate it. This talk has been in the making for 5 years. I've come to the previous conferences here, and the one thing that I've been looking forward to talking about was how we ended up finishing this project, because it didn't seem like it would finish in the beginning. So I work for Autodesk, and the product that I'm working on is called Alias. Alias is a very rich history. I wish I could do a talk on that, because it was founded in Toronto in 1985, and first commit was in 86. And ever since then, it's a product 35 years old, with people working on it for decades. And it is used for, as you can see, for industrial design, surface modeling, mostly used by car companies, also toy companies, like wear like glasses and such are designed using Alias. And one crucial thing about Alias, anybody uses Vim here? Okay, or Emacs, that's fine too. It's similar to that. So Alias users see Alias as their Vim, they have muscle memory for this, and their job is to sit in front of a computer for 8 hours and then just put in CVs and vertices and try to build something. And these models, they take a long time to build, and that's why we have 800 tools to make these things easy to do for you. And since it was done in the 80s, there was no UI toolkits back then. It was done internally. A toolkit called Edwin was built in 87, and then over the years, it's a C library, and over the years, it just got built and built and built for new modern technologies, more modern UX necessities that was coming up over time. But it got to a stage, as you can see, for example, here, got to a stage where it was hindering the progress of the application. There were certain things that we couldn't do because of the 35-year-old baggage that we weren't able to maintain. And at some point, the UX would come and say, can we do this? And developers would just say no. And there was no argument, because the UX knew that we actually couldn't do it. So we wanted to change all of that so that we can move forward into the 21st century, implement some new things, but also still keep, they call it the soul of Alias. It's like the soul of Emacs or Vim. You want everything to stay the same, because there's a lot of muscle memory built into this. So we wanted to improve definitely the UX to make it easier for newcomers to use Alias, because more and more people are coming to Alias from university, kids born in early 2000s, and they don't know what any of the UX from the 80s look like. So they're used to the new stuff like Adobe and similar applications. And that was the important part, but one of the important parts for us was to pay off a lot of debt that we accumulated, re-architect the system. So this wasn't just about having a pretty UI, but improving the UX, improving the architecture so that things are easier to add now, so that when UX comes in and says, can we do this? We can just say, yeah. And there was a catch, though. We wanted to change everything, but we still had to keep everything the same. So initially, when the project started, everyone was like, let's replicate the existing UI so that we don't change anything, because if we change something that people don't like, there's going to be a backlash, obviously, because you spent 8 hours on this thing. You don't want anything to change. Well, change for the better, but if it breaks your muscle memory, things are going to be very difficult for you. So this project had 3 scopes. We had to change the architecture internally, the underlying system. We need to change the design to make it more approachable for newcomers. And we also needed to simplify, since we're at it, simplify some workflows so that instead of doing 3 clicks to achieve something, the user can do 1 click. Or instead of the mouse travel being from all the way to the left of the screen to all the way to the right, maybe they can just keep in the same space. But all of that are just the overarching goals, but underneath it, we have a lot of problems to solve about data management, the themes, how do we handle that, workflow updates, UX improvements, UI improvements, and all of this needed to be done in a separate branch. Because in our case, but there was actually some talks yesterday in the keynote about making Qt easy to use with other toolkits, but since our toolkit was homegrown, it was hard for us to make both of them live at the same time. So this was a project that was running in parallel to the shipping product. And the developers who started it was exactly that, thinking, how do we start this thing? Because it's such a overarching goal, such a big 5-10-year goal maybe, because they don't even know if they can even succeed at this. So the way to start this for them was just to start slow, in a way. But we also need to be fast, because we have a shipping product on the side. There's some resources that's being allocated to this. It needs to go, right? We need to tell the stakeholders that there's progress, that there's value in this. So since we needed to go fast, we thought, OK, let's start just with 1 or 2 developers. 2 developers, our software architect and another senior engineer, Wayne and Dan, started the project. They essentially wiped out all the UI that we had from the previous toolkit, Edwin, and then started with a rectangle on the modeling windows and just the main window to see how they can get things done. But over time, they ran into situations that they needed to handle, so there was some training that needed to be done, figuring out things, how to achieve certain things that existed in Alias for 3 decades and make it compatible with something that's modern. So at some point, you realize that, fine, we're going fast. Now we have a bunch of menus, but every time I click on those menus, there's an assertion that says this hasn't been implemented yet, and there's about 800 of those menus. So somebody has to do this work, so 2 developers are not going to cut it. So at some point, more and more people started joining, and that's when we got more into thinking about, OK, we're changing the way that changing the technology, but maybe let's look into how we can change the way that we work as well. And in this, I'll briefly mention what's in the main function. I won't get into the detail a lot. Some of the interesting parts of the data transfer from the core side to the UI side. I wish I could do a longer talk here about that. And including designers and the thing that enables us to include designers easily at the end, where we extend on the templates and style architecture of Qt Quick controls. But before that, briefly, we essentially added 1,028 files. Thankfully, a lot more were removed, though. So this was just a new folder that we added, everything that was added to new folder, but underlying architecture stuff, a lot added, but a lot more were removed. I think there were, probably 3,000 or 4,000 commits at the end of the 5 years. And we actually just released last June, so we were very happy about it. So inside our main function, we're using QGUI application with one main QML engine that handles all of the UI stuff. But we have additional things running on the side. Like we have a thing called marking menu that is gesture-based, and it has to be very, very fast. That was one of the challenges that we had, because our users can detect 1 millisecond. We look at it, some bug report comes in, and they're like, this thing is slow. We look at it, and it's pretty fast to us, but they're like, no, it's 1 millisecond. It pops up there and stays there for 1 more millisecond. And it was very challenging. It was actually an intern project as well, so he took just all 4 months trying to look into how we can improve this. He ended up having a lot of fun with it. And the entire application, the new site that we're building, is pure Qt Quick and QML. We had some widget in the beginning, QWidget files. But later on, we switched everything to QML, and there's nothing else underneath. And mostly in our project, we rely on the Qt Quick and QML modules, and mostly nothing else for our UI. Data transfer was one of the most interesting parts of working on this project. We had a lot of data that needed to be transferred to the UI because we have editors with millions and millions of rows sometimes, and all of that has to make it to the other side in a fast and efficient way. And the way that it has been done for decades was using stuff actually similar to things like Q properties and a container for those Q properties. We call them symbols and symbol table. The symbols contain various data types that you can extend and add a vector type or a point type and various other things as need be. And the symbol table is essentially just a fancy container around it that gives us the opportunity to do additional things on top of those symbols. And the initial attempt with all of that, because the editor information is included in that, the initial attempt was to have virtual interfaces for most everything that we had in the core. So we would have a core editor with some virtual functions and some other implementations underneath. And then in the quick side, we call it the UI side, the quick side. In the quick side, we would have the implementations for those things. But we didn't just have editors. We had those symbols. Each symbol needed to make its way to the UI. So somehow, each symbol needed to have a representation in the quick side. So we ended up having a lot of, we call them control base, control int, to represent an integer. And we ended up having maybe 15 of them. Whenever we needed to add something new, there had to be a new file, new implementation, a lot of boilerplate. And since we have about 800 tools, like maybe 500 editors. Not all of them had special classes like this, but when we needed to handle something specific, that meant we needed to have n number of class hierarchies, class instantiations for that information to make it to the core. So we realized this really sucks, because we are doing a lot of boilerplate to just transfer data from one place to other. Every time we needed to expose something new or remove something, we had to rebuild everything, and that ended up wasting a lot of time, writing a lot of boilerplate code, which also meant a lot of things to maintain. And thankfully, we realized other things. And those things were, we have in the structure that we're using is sort of like a JSON-like object, and we want to be able to export that to the UI directly and then make it only go through one system. Anybody familiar with Redux or Flux architecture here? Okay, Redux and Flux is an architecture to manage the state management architecture for UI applications. It's usually used in the web development, but that was an inspiration point for us so that we can change how we handle the state to have more control over it, and data flows through just one pipe. We have control over how that goes, so that, for example, maybe we want to do more prototyping and we don't need to launch everything, initialize everything that's underneath. We just have an empty shell of a UI. The designers can come in, experiment with things, do some user testing, and then if we need something full, we can then again load everything, and then we have a fully reusable app. I wish I could get into it more. I had a different talk about this in Greece that was really nice, but maybe one day I'll get to talk about it here as well. At the end of it, it looked like something like this, where we have our custom data type, that is our symbol table, that contains multiple other data types, strings and vectors and various other things. And in order to access it on the QML type, we had a new class called symbol table model. And if you notice that each property there corresponds to each symbol type on the core side. And this is just one-to-one relationship, and you don't need to have, just because it's exposed here, doesn't mean that we need to have it here. So on the QML side, we have a lot of control over what we need to expose, what we don't need. And maybe sometimes the information here is added for C++, the core side needs, and they don't need to be exposed here, so we don't pay the penalty for those, for the things that we don't use, which was nice for us. And another cool thing was, notice this callable type. It's a function with a lambda, and we were able to also export it to the QML side using this syntax, and when you call it, it actually calls the underlying function. And there are cool ways that we can do, since we control how these things work. You can get into asynchronous stuff, like without necessarily locking, because you can just stop the connection to the core. Nothing is happening, so you don't really need a locking mechanism there. Another cool thing with this is, since we control how these types are exposed, and we're relying on the QML types here, that means we can also export our own custom types that can do special things underneath. For example, for the thousands and thousands of controls that we're exporting, we had a special abstract item model that did special things underneath for things to be more efficient or include some more functionality, and that meant we just needed to say, I have these controls. Instead of making a list model, just make it a control list model, so we have more functionality over this. And the way, in a very high-level way, the way it works is we have our symbols. They're also notifiable. Somebody changes some data in the core side, and we clone those symbols to the UI side. Whenever the clone, the source symbol changes, it sends a notification symbol to the clone. The clone notifies our symbol table model that does special type checking and a few other things to ensure that the data type that we're exposing and the type of data that we're exposing to the UI side matches what the QML side thinks it is. So if there's any problems with the data type mismatch or maybe a typo, all of that can be handled here, and then we get a nice, hopefully nice error message, which wasn't nice in the beginning. We had to work on it a little bit. And after the property is updated, the QML side can react to multiple things and then even update some other properties, and that'll make its way down to the core, and then the core will decide what to do, and maybe that'll update something, and it'll be a loop like this. The pros of this is numerous. And probably the most important one for us was the flexibility that it provided, because it meant we didn't need to compile anything when we changed something because a lot of it was already in the data type. It just needed to be exposed. That also meant when somebody coming in and adding a new, let's say they want to add a new UI widget to an existing editor, they know that that data exists there, so they just expose a new property to get to the information that they need, and they start doing their thing without even needing to rebuild the application itself. And it also provides a way for us to declaratively declare those properties, so you get nice things like if you're using Qt Creator, you can have nice code completion for this because there's nothing underneath. We're not exposing a C++ object. It's literally just a type that's declared in the QML side. So Qt Creator can read that and then provide some code completion for you as well. And this also meant since we had a similar architecture, a similar type to a JSON, we also changed our system so that we load from JSON. That means that we can export a state, import a state, and the application can be still the same. Or let's say you have a special workflow for you that includes like going into multiple menus. You can just get to that state, save it, and then import it again at some point when you need to do more testing or when you need to achieve something. Sadly, there are some cons, and one was especially about debugging, which was in the beginning a bit hard because it was a different system that we were getting used to as well. So sometimes we weren't able to see, oh, is this type really exist? Like, where do I get to this? And we had to find some ways around it, which mostly involved like communicating to the developers, adding some documentation there for them to find out where things are going. But the nice thing about this is, especially if you're doing some code function calls, you can just put a breakpoint, and then you'll be able to follow the entire stack trace to see where things go. And the unfortunate side of it is that the static type checking is runtime, not really, like we can't really do it as it's building or as it's launching. It has to get to that window for that information to make it available, and we can check it. And over the years, in the 5 years, when we're building the underlying architecture, there was a lot of we're having conversations about it. It's considered a UI project mainly, but when you talk about non-UI related code, this is usually what it feels like. Does this resonate with anybody? Anybody's like, oh, I've spent 2 days, and it actually felt like 2 days when I was working on this. And this was the consensus among us. But then when we needed to do some UI-related work with developers, they're like, this is taking forever. But I would tell them, you've only spent 10 minutes on this, but it doesn't feel that way to them. And this made it obvious that we needed somebody who actually enjoys doing this sort of work, right? So that it's not a lifetime to them, but it's something that they enjoy, and they feel more empowered by the work that they're doing. So that meant we had to include designers. And that also meant that we needed to provide some tools for these designers to help us, because there was work that needed to be done we didn't enjoy doing, but we're professional, it has to get done, so we bring in somebody else to do it, right? So we had some trainings early on in the project. We were already talking about this, the benefits of it. We were like, here's the technology that we're using, and here are the benefits of it, and you can actually do so and so things on your own. You don't need to talk to us anymore, but you need to learn something. Which for some people, it might be a hard selling point because they're designers, they don't want to code, but we were lucky enough to have some people in our team, actually across teams as well. We organized some trainings, QML trainings internally. I had people joining from some other products, even QA people were interested in this so that they can see how this thing's done, because sometimes they also run into situations where they want to change and they don't want to talk to developers. Nobody likes us for some reason. And since we started doing this, we also thought there are other ways that we can also make things more customizable. So with that JSON object that I mentioned before, we started exporting it to file systems so that those things can be customized by QA people or product managers and everybody else. So this meant that we not only included designers, but we included everybody in the project, because nobody felt like there was a barrier. There was a ticket that was created, and we just assigned it to the designer, even though they probably intended it for us. Because we would tell them, this is an easy thing. You learned how to do it, you can do it. And to get there, though, was not easy. It required a lot of patience, a lot of training, and sometimes, especially in the beginning, when you're trying to teach them something, it feels like it's going very slowly, And it actually is going slowly, so your feeling is valid, but you have to power through, make it to the end, because at the end, they're going to save you a lot of time. And I will show some showcases of this at the end, where there were cases I didn't even know that that thing was being done, and suddenly it appeared there, which was an amazing feeling. And in order to achieve that, anybody familiar with the styles and templates and the Qt Quick controls? They have that as well? Okay. Okay, a brief explanation is that they have in Qt Quick Controls 1, they had it as, I think that it was implemented the template side were QML, but in Qt Quick Controls 2, they had their C++ types that would explain what happens when a slider moves, what happens when a button is clicked, but none of the visual information will be defined there. And then they have a QML type that passes in some information, like a content. I'm sure you assigned a content item or a background item at some point, and those are the things that visually provide information. Because as far as the C++ type is concerned, I only have a real float value that I'm manipulating, but I don't care how it looks like on the other side, right? And we took that approach, extended on it, and made everything that we're doing into a template and style. This made things easier for us because now the developers, at least even when they did QML UI work, they only did the non-UI UI work, right? And that was easier for them to get started. Then they would sometimes put in some placeholders, rectangles, like ugly-looking things, and because we didn't care. And they didn't feel the pressure of moving it 1 pixel to the right and making the hue a little bit different. So the workflow looked kind of like this. The developer involvement was just in the beginning when a new type was being exposed, for example, which actually later on changed. The designers did end up getting into the template side. They would look into the code. They actually turned into kind of like developers. I was joking that they're taking our jobs because they would go into the template side, look in the code, even change things in there, then go into the style side, add new files. Like they were even talking about refactoring, which was really nice. So the developer involvement would only be in the initial template state, where something has to be exposed because maybe there's a connection, and they would be the ones initially creating the symbol table model declaration, for example, and tell them, here are the things that you can do. And then later on, we would pass it on to designers. They would do their own thing, but initially, this sounds a bit cumbersome because we don't have much, right? But once we had a lot of code, that meant we already exposed a lot of things in the back, and we already have a lot of experience doing this. So this process was pretty fast. And in some cases, we weren't even doing it. Some data was already available in some other place. It just needed to be transferred to maybe inherit from something else, and designers usually took care of that. And at the end of it, they would create their PRs. I would review them, leave comments. They would change things, and then we would eventually merge them. And this also meant, one of the good things about this was, I was telling somebody yesterday, when they create a ticket because something doesn't look right, we were able to just say, that's your mistake, not me. Okay, so finally, the title, the good, the bad, and the ugly part of it. It was a five-year project with a lot of good things that we encountered during the duration of the project. There was good support, especially in the beginning. The integration of our existing OpenGL code with Qt Quick was pretty easy. There wasn't a lot of pain in doing that. Then, especially since new developers are coming to this and designers are coming to this, the documentation was fantastic for it. We could just refer them to that, especially after some initial exposure to it. They could just go and check out the documentation themselves. That was really useful. And the development got even faster, especially after we had some initial scaffolding for us to build faster. Because one of our developers, he'd been working on the project for maybe a year, and then there was some need for him to be in the main project, the shipping product. So he went back to that using the previous toolkit. And the entire time that he was doing his work, he was just like, this is much easier than the new thing that we're doing. Why are we still doing this? And he was complaining about it, which was, I think this was about maybe 1.5 years into the project. It was nice to see that change, that feeling that he had, because it confirmed that we were on the right path. Flexible and fluid UI is definitely one of the benefits, because now with the list views, transitions, and the animations that we can do in other places, the designers could just go in at their animations because we didn't care about them. They just needed to show up somewhere, but they had the ability to change how that thing shows up. Actually, the Q abstract list item model was one of the great things about this. We were able to really use it in such a way so that it integrates well with the symbol table model, the symbol table data structures that we have in the core, and that gave us the ability to customize the functionality of it and then make that existing 30-year-old thing into something modern that can be manipulated declaratively in the QML side. The bad is the integration with OpenGL and high DPI. I'd been talking about this, I think, for the last 3 years at least, with people at these conferences, with some other people. And apparently this is a known problem and without a known solution to it, which is the unfortunate part. But what we ended up doing is, because we couldn't use the high DPI support of Qt, we had to implement our own high DPI support within it. And that was good in a sense. That gave us a lot of flexibility about how we scale our UI, a lot of granular control over it. But it's still a pain because it's extra thing and an extra layer of complexity and extra class that we have to maintain. There was event handling. This was, I think, the event handling in QWidgets and Qt Quick, it works differently. In Qt Quick, when an event is received by an item, that event is captured by that item, and the next event stream that comes in, they only go to that one until that event stream is corrupted. And in our case, since I mentioned that Alias is a bit of a gesture-based applications, and this applies to menus especially. So when they go in, when they don't do a right click, they just do a right press, something pops up, they go over it, do whatever they need to do, and then they release to execute that action. And we weren't able to do this, and this was, at some point, everyone was like, have we made a mistake? If we can't fix this, people are going to have a problem with it. And initially, we were thinking, we have a lot of good things going on. I'm sure they won't mind this. But 4 years in, they did, a lot of them. So we had to find a solution for it. And that's the ugly part of it I'll get into. Performance problems with initiating a lot of Q objects was initially a problem, especially when we were doing a lot of those virtual interfaces with control base, control int that I mentioned. There was a lot of them that we needed to create. And when we were exposing them initially, the initial implementation used a QML property map for some cases because we needed a named access to those properties. That was also a bit slow. And also hard to discover because we didn't know what was inside that thing. Multi-monitor support is still a problem for us, and that is something that we're still actively working on and trying to fix it up. But the good thing about this is, actually, I have it here. The open source nature of Qt makes it easy so that at least we can go into the code, follow certain things, and be like, OK, here's the thing that they're doing, and here's where the problem appears. Maybe there's a solution here that we can do. So we were able to at least understand how that problem occurs so we can have a better workaround for it. And the lack of tree view support was a huge problem for us. But now in Qt 6, I believe there is a tree view, and we are working on our Qt 6 port right now, which could be another talk on its own because we started this 5 years ago, and we didn't have time to do that migration. But we also had to come up with different ways of handling this tree view support with a lot of flattening of tree structures so that that can also be efficiently shown because we have an editor called Object Lister that can contain millions of objects in there because it contains all the information that you would see inside a model, and these cars has lots and lots of data. The ugly side is essentially all the workarounds that we had to do for the bad things that we saw. And supporting that last bit was especially painful. We work with internal developers, and we had some contractors with this so that they can invest additional time on it as we're working on some other things. And what we ended up doing is just duplicating a lot of events, transmitting them, taking them from one place, moving to another, but still the source is the same window. And we had to do some child event filtering happening there and do a bunch of special cases because the way that the properties are being updated with these Qt quick controls depends on the fact that I'm only going to receive it once. Everything else will come in after that event, so they don't really check for that, right? So we needed to make sure that once a hover event is received for a menu, for example, it first receives maybe when a hover event is received, maybe it first receives a press event so that it understands now the events are coming in, it can do something if we're doing a slider interaction there and whatnot, which was a lot got into a state where it was hard to understand, but once you understand it, it's actually easy to maintain, but understanding it is what makes it hard to maintain in the beginning, because that event handling, it, in its nature, is very dynamic, and it's very hard to reason with events in that case. Custom high DPI handling it has one issue that apparently some other people had the same issue, because they also had some OpenGL content, and they ended up doing their own custom high DPI support. And with this one, if we have dynamic sizes, for example, we have docked window, and if docked window is somehow the size changes by mouse, and you move to another monitor with a different DPI, then it's hard for us to say, okay, you're 100 pixels in the previous monitor, now you need to be 200 pixels. That still we haven't resolved how to do. So when you move from one monitor to another, sometimes we get into a stage where you had a perfectly sized window here that showed just the right amount of information that you wanted. You move to another one, now you have to do a resize again, which is unfortunate. So all that work, 5 years of work. Has anybody seen The Good, the Bad, and the Ugly? Oh, awesome. Okay, all of this worked for you then. So at the end of it, we went through a lot of trouble and trials and treacherous roads with initially 2 developers, starting with 2 developers, up to 15, 18 developers near the end. And with a lot of time constraints, even the one thing that we had, for example, we called it, instead of a minimal viable product, we call it a minimal viable berry, one of our internal coworkers there, who's been using Alias for about 30 years, and he's master at it. We just had to convince him that this is a good idea. So that was very stressful. But 5 years long, at the end of it, we were all weary. We were looking for something to say, okay, we did it. Finally, it worked. And it did. We're happy with the result. Customers are happy with the result. And they can see that it feels the same way, because one thing that one customer was saying, which was really interesting to me, he said, learning Alias is like learning to play the guitar. When you're learning, you look at the chords and try to see what's going on, but once you master it, like, you don't look at anything, you just go at it, and it just works, right? And thankfully, we didn't lose that aspect of it. Alias still just worked, thankfully. And it still worked the same way that they did, with maybe some little changes here and there for the better, because that meant they needed to do fewer clicks there, maybe less mouse travel here. And the templates and styles meant the designers were happy, because everything that you see here, the interaction, is that playing? Oh, interesting. Okay. This interaction that you see here with the title bar showing up in the beginning, and then as you go lower, like the UI changes, the layout changes, the title bar disappears, something else shows up. I had nothing to do with that. All of that was done by one of our designers. And he later on, because this was such a long project, he actually got promoted to the director of UX, and he had a lot more meetings during that time. And he would complain. He's like, God, I miss coding. Like, I need to get back to it. I'd sometimes work after hours to just get a few things done. And this part was, remember when I said there would be cases where something would show up in the UI and I don't even know about it? This was one of those cases. This was done by our designer, Dorothy. Started from scratch. I didn't even know that she was working on it. Someday, he messaged me and said, Furkan, I'm having a problem with so-and-so thing. Can you help me? She showed me the window, and it looked pretty good. It worked pretty good, and I showed her a few things. And like as these mistakes, they actually learn. So they ask less questions. Because in the beginning, we had weekly check-ins. 3 times, actually. We would have 3 meetings, like 15, 20-minute meetings, so that they can ask some of the questions that they have. We can go over some of the core concept of QML, maybe show them around the code base so that they get more comfortable. But these days, nobody talks to me. But before, they used to talk to me a lot. And one other thing that was really special for us was the docking implementation. This is a pure, cute, quick QML docking implementation with all the bells and whistles, some additional things. Like, our initial implementation was actually so powerful that we didn't know how to wield it, so we had to scrape it away and then start something new, because it got to a stage where all that power meant it got too confusing. So we needed to take some of that away. And this was the implementation that we ended up with, where you could group together floating windows on the side, move it to a different window, like dock them in the main window. And there was the special things that we were doing with the event handling. I actually had some experience from this, because when you go from clicking on the main window, pressing on the main window, and moving the window out of that main window, we have to create a new window for that new content and then transfer the mouse events to that new one so that you can still keep dragging the window, right? And that, thankfully, we ran into that issue so that we had some more experience when it came to the menu problems. And this part of it was also implemented by our designer, where you just show up certain things, like even collapse them to the side, change the, for example, sometimes the initial implementation had the windows above the layer bar that you see up there, but he didn't like it, so he just changed it. This is just a basic code to illustrate how the docking is done, at least in a declarative scale. We just have some models. Well, you declare the dock controller. This means that you can style the dock controller in any way that you want. And we have some attached properties for it, like a few other things that provide a lot of context for you, so you can have a lot of customization for these things. And we have the window, everything that's floating. When you dock two windows together, we have a new window that everything else is docked to. And that one is the floating window. That also means that you can style it in whichever way you want. So, which was a nice part, because when I was implementing docking, I just created a new window, just pure like regular window, and I just tell them, do whatever you want with it. I don't care. And they didn't care what I did underneath, as long as it behaved the same way that they wanted. And this was also something that our designers, I'm very happy to say that this was all done by designers. I didn't say developers so far, if you noticed. This was done by one of our designers as well. He actually had, as he was learning QML, he created a whole new prototype for himself from scratch that looked almost exactly like what Alias looks like right now. But he was building that as he was learning QML, so it was hard to look at the code. But later on now, the code that he writes is much better. And this is the dynamic layouts that we have, where the density of information changes as you're expanding the window, making it narrow. And the window space, monitor space, is very important for our users. So designers really took care into making sure that when things are smaller, you can still use it in an efficient way, but you still get that additional space. This was also, the collapsing behavior is here was also meant for that. So finally, the end result looks like something like this, with a lot of things going underneath. I wish I could dedicate 30 minutes to each of the things that I talked about so that I can go into detail, but the marking menus that we did before, the dragging and dropping functionality that we had, especially the performance things that we're running into while implementing marking menu, was very interesting or very challenging to work on. And at the end of it, I'm happy to say that we don't have as many developers working on this side anymore. We're just a few people in that Alias, we call it Alias Experience team. And we are continuing to work because a lot of the things that needed to be done now there, and it provides us a lot of flexibility and power to do whatever we want. So these days, as the project was going on, actually, one of the things that I kept saying to designers was like, we're working on it in such a way so that when you come to me with a request, I never say no to you. And then when you ask me to do it, I can always say, you go do it, which thankfully worked at the end. Thank you very much. In the previous talk that I attended, somebody said there was a banana in their talk, and if anybody noticed, it was like, if you noticed it, good job to you. There was hats throughout this talk. I don't know if you noticed. I had the title before, I love Westerns, and I had to put a lot of cowboys in there. Thankfully, it worked along with the presentation. Thank you for listening.